Welcome to my channel, Mummy's Wiz. Today we are going to learn about the lesson called electric currents. Friends, during the end of the video, if you like the video, don't forget to like, share, comment and subscribe. So friends, now let's get into the lesson. First, let's learn about electricity. The most convenient source of energy is electricity. Electricity has a very important role because it is used to run many electrical appliances like an electric bulb, television, a stereo system, refrigerator, a washing machine, computers, and etc. And we cannot think our life without making use of electricity. Electricity is produced at power stations from where brought to our homes through the thin wire and electric poles networks or underground cables or wires. Here we can define the electric current as of the flow of electricity through a conductor, wires and cables. Actually, in everyday life, the word electricity and electric current are used in the same sense. There is another source of electric cell or battery. Now, in order to obtain electricity from a cell or battery, we have to connect it into a circuit. So, let us study about the electric circuit. Electric circuits. A continuous conducting path consisting of wires, bulb, switch, and etc. between two terminals of a cell or battery along with an electric current flows is known as an electric circuit. Example, take a cell having a positive terminal plus and a negative terminal minus. Now try to connect the positive terminal of the cell one end of the now try to connect the positive terminal of the cell to one end of the switch with a piece of copper wire and other ends of the switch to one end of bulb holder with another piece of copper wire. The negative terminal of the cell is connected directly to the other end of the bulb holder with a wire as shown in the figure. So this kind of setup is known as an electric circuit. Next, this is an example and a diagram of an electric circuit. So, let's learn deep about that diagram. Circuit diagram. A circuit diagram tells us how the various components in an electric circuit have been connected by using the electric symbols of the components. When the bulb glows in an electric circuit, when the switch is closed, then the switch is said to be in on position. And when the switch in a circuit is open, then the switch is said to be in an off position. So in electric circuit, a bulb lights up only when the switch is in the on position, and at that time we can say that the electric circuit is complete because the current flows throughout the circuit instantly as shown in the figure of electric circuit. When the bulb does not glow while checking the circuit, notice that sometimes the bulb does not glow even when the switch is in on position. This condition can occur only if the bulb gets fused. Example is filament breaks. It is a difficult and time-consuming job to draw the electric circuit by making the actual drawing of cell, battery, switch, bulb and etc. Next, let's see about circuit diagram of electric circuit and another circuit of diagram. So the first diagram is in on position and the second diagram is in off position. So let's learn about that. So the scientists have devised a very easy way to represent the component of an electric circuit, cell, battery, switch, bulb and etc. with the help of symbols which are easy to draw. Next, let's learn about electric cell and battery. The common source of electricity to run the number of devices, example torches, radio, electric clocks and watches, toys and etc. is an electric cell, but sometimes a single cell is not sufficient to run many devices as they require high voltage to run all these appliances. The cell provides much less electricity as compared to that provided by the electric supply line. Example, in the case a single electric cell which provides only 1.5 V of electricity, whereas electricity formed from the power station is supplied to a home at a high voltage of 220 V. Due to the flow of electric current is called the heating effect of electric current. We have seen an electric heater used for cooking, an electric bulb or room heater. So when these appliances are switched on after connecting to the electric supply, then that element become red hot and release the heat. This happens due to the heating effect of electric current. The degree to which a material opposes the passage of current through itself is known as its resistance. Actually, when an electric current passes through a high resistance wire, the electric energy gets converted into heat energy, and this heat energy heats up the wire. Next, let's see about element. While all electric heating devices consist of a coil of wire called an element. When these appliances are switched on after connecting to the electric supply, then the element becomes red hot and release the heat. There are some electric appliances such as immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers and etc., which have elements inside them. Factors on which the heating effect of current depends. There are two factors on which the heating effect of current depends. Resistance of wire. Greater the resistance of wire, greater will be the heat produced in it by a given current. Example, if we choose two wires, one of the copper and the other is nickel, of through them for the same duration, then will be noticed that nickel wire will become hotter in comparison to the copper wire. It is due to the reason that is why the nickel wire is used to make heating elements of electric heating appliances such as electric room heater, electric iron and etc. This resistance of a wire depends on the material of the wire, length of wire and thickness of the wire. So friends, next let's see about magnitude of current passed through a given wire. If the magnitude of a current passed through a given wire is greater, then the heat produced in the will also be greater. Example, if a normal amount of current flows through the copper wire of household electric wiring, then the wires do not become much hot. But if a large current flows in the same wiring accidentally, then the wires become extremely hot and fire may be. So next we are going to learn about application of heating effect of a current. Some of the important applications of heating effect of the electric current are: for the production of light, the heating effect of electric current is utilized in the electric bulbs. For the working of electric heat appliances such as water heater, electric room heater, electric iron and etc. The heating effect of electric current is utilized. The heating effect of electric current is utilized in a safety device called electric fuse. Next, let's see about compact fluorescent lamps, which is shortly known as CFLS. An electric bulb is basically used for producing light, but it also releases an heat which is not desirable because of a major part of the electric consumed by the filament of a bulb is converted into heat and results in the wastage of electricity. So, this wastage can be decreased by using fluorescent tube lights or CFLs as shown in the figure. In the place of the bulbs, however, before purchasing bulb tubes or CFLs, we should look for the ISI mark, ISI Bureau of Indian Standard. It is because the ISI mark ensures that the appliance is safe and wastage of energy is minimal. Next, let's see about electric fuse, a safety device which works on the heating effect of current and prevents electric fires or damage to electric appliances due to excessive flow of current is known as the fuse. The safety device consists of a short length of a thin wire of thin plated copper having a low melting point, and this wire has a much greater resistance than the rest of the electric wiring in the house. So due to this, if the current in the electric wiring suddenly increases too much, then the fuse wire gets heated and it melts and breaks the circuit, which means the current flowing in household circuit will stop. This prevents fire in the house and also damages the various electrical appliances like refrigerator, fans, tube lights, TV, and etc. When a fuse gets blown, breaks, a new fuse has to be filtered into place in order to be restored the electricity supply in the household. Cause of a large current flow in the household electricity. Wiring an extremely large current can flow in the household electricity wiring circuits under two constraints: overflowing and short circuit. We might have read reports in the newspaper about fires caused by short circuits and overloading. Now let's study these two terms. Okay, first let's see about overloading. It is situations when too many electric appliances are connected to a single socket. They draw an extremely large amount of current from the household circuit. The flow of large current due to overloading may that the copper wires of household wiring to a very high temperature and fire may be started. Next, let's see about short circuit. Let's see about short circuit. Electric current is supplied by household through insulated wires which run called live wire, and the other insulated wire is called natural wire, and both these wires are necessary for the working of an electrical appliances, say an electric iron. So if in case the plastic insulation of the live wire and natural wire gets worn due to wear and tear, then the two naked wires touch each other. So this touching of live wire and natural wire directly is known as a short circuit, due to which a large current flows through the household wiring, and this large current may heat the wires and dangerously high temperature and fire may be started. Note: always use proper fuses which have been specified for particular appliances carrying ISI mark. Never use just any wire or strip of metal in a place of a fuse. Miniature circuit breaker, which is shortly known as MCBs. These are increasingly being used these days in a place of fuses. MCB does not work on the heating effect of current as it works on the magnetic effect of current. These switches automatically turn off when the current in the circuit exceeds the safe limit. We turn on them and circuit is once again complete. So, next, let's see about magnetic effect of electric current. In the electric current pass through a wire, then the current carrying wire behaves like a magnet. This phenomenon is known as the magnetic effect current. It was discovered by scientist Hans Christian Ørsted, who found that when an electric current is passed in a wire, then the compass needle placed near it got deflected from its usual north-south position. A straight wire carrying an electric current produced a magnetic effect. The magnetic effect is increased only if we use a long coil of wire instead of straight wire Even further, the magnetic effect is increased in the coil of wire is wound around an iron rod and then current. Next, let's see about electromagnets. It is a magnet made by using electric current. An electromagnet works on the magnetic effect of current. An electromagnet consists of a coil of insulated wire wrapped around a piece of iron which is magnetized only when an electric current is passed through the coil. Next, let's see about the magnetic consistence of a long coil of insulated copper wire and around an iron rod. And when the two ends of the coil gets connected to a cell, then a current passes through the coil and produces magnetic effect. The magnetic effect magnetizes the iron rod. In this way, the iron rod becomes an electromagnet. The magnetism of an electromagnet remains as long as the current is flowing in its coil. So if we switch off the current in the legs, then all the magnetism of iron rod disappear and it will no longer behave like a magnet. Now, let's see up. And then by increasing the amounts of current used in the coil, by increasing the number of turns forming the coil. And then now let's see about uses of electromagnets. The magnets are used in electrical appliances such as electric bells, electric fan, and electric motor. These magnets have their utilization in electric generators where the very strong magnetic field is required. For deflecting electron beam of the picture tube of TV, electromagnets are used. For the magnetic separation of iron ores, the earthly substances, electromagnets are used. For preparing strong permanent magnets, electromagnets are used. So, next, let's see about advantages of electro over permanent magnets. An electromagnet is a temporary form of magnet because its magnetism is only for the duration of current flows in its coil. Actually, an electromagnet is better than a permanent magnet in many respects. There are some of the advantages following of the electromagnet. Permanent magnet which are started as flows. The magnetism of an electromagnet can be switched on or switched off as desired, while it is not possible with a permanent magnet. By increasing the number of turns in the coil and by increasing the current passing through the coil, an electromagnet can be made very strong. On the other hand, a permanent magnet cannot be made so strong. Next, let's see about the electric bell. An electric bell works on the magnetic effect of current. It has an electromagnet in it. Let us study the construction and working as well. So, construction of electric bell. The electric bell has a U-shaped electromagnet. This is a small iron bar called armature which is HD in front of the poles of the electromagnet. The lower end of the iron bar is attached to a flat spring and flat spring is itself fixed to a metal bracket. The upper end of the iron bar has clamp attached to it. Metal along is fixed near clapper. So next, let's see about working of electric bell. In order to ring the electric bell, first of all, we press the push button such switch in the ring the bell. So when we press the switch, then the electric circuit of the bell is completed and the current passes through the coil of electromagnet and it gets magnetized. The electromagnet attracts to the iron armature towards itself. So as the armature moves towards the poles of the electromagnet, the clapper attached to it strikes the gong or produced a ringing sound. It simplifies that the bell rings. And next, let's see about when the armature moves towards the magnet, its contact when the contact screw is broken. Due to this, electric circuit breaks and no current flows in the electromagnet coil. The electromagnet loses its magnetism for a moment and armature is no longer attracted by it. The flat spring brings back the iron armature to its original position, and the clapper also moves away from the gong. As soon as the armature comes back and touches the contact screw, the circuit is completed and current starts flowing in the electromagnet coil. The electromagnet attracts the iron armature once again and the clapper strikes the gong again, producing a ringing sound. So this process of make and break of the electric circuit continues as are pressing the switch. Due to this, the armature vibrates forwards, backwards, rapidly each time, making the clapper strike the gong. Thus, the clapper strikes and gong, producing the almost continuous sound. So, friends, that's all for today. Today we learnt about the lesson called electric currents. So, friends, don't forget to like, share, comment, and subscribe. If you subscribe, don't forget to press the bell icon. So friends, let's meet in the next video. Thank you.